Now we'll move on to look at how to determine the number of fans for mechanical ventilation. The method is not complex, and it is simply to divide the volumetric flow rate that is required per reservoir by the output from the individual fans, and then to round this up to give the minimum required number of fans. However, in some situations there is a possibility that the hot smoke will detrimentally affect one of the fans, and in such cases the design of the extraction system should allow for the loss of one fan. For example, the fire might be located directly beneath one of the fans, thereby exposing it to temperatures greater than it was designed to withstand. In other words, even with one of the fans not operating, the other remaining fans should have an aggregate capacity of at least the required volumetric extraction rate. This discounting of one of the fans is not required where there is no possibility of losing a fan to the fire. This would be the case in a divided building, perhaps where there is no fire load directly underneath the fans or the intakes. It is not assumed that any fan will be lost for any other reasons, such as simple mechanical failure. The fans must have duplicate power supplies and should be subject to regular servicing, so they should be reliable. Standards are laid down in BSEN 12101 Part 3, 2002. So let's suppose, for example, that we have calculated that there will be up to 50.35 cubic meters per second of smoke entering the smoke layer, and that our designer wants to use fans with a capacity of 11 cubic meters per second. Let's further suppose that the distance between the fire loading and the fans is small enough to mean that we might lose one of the fans to the fire. How many fans do we need? Well, 50.35 divided by 11 is somewhere between 4 and 5. We don't have to calculate it precisely, as we have to round it up anyway to 5. So we round the answer up, and 5 is the number of fans that are required. But then we have to add one fan because we might lose one to the fire. And so the result is that we shall need 5 plus 1, which equals 6 fans, each with a capacity of 11 cubic meters per second, and in each reservoir. If none fail, then we shall be extracting 66 cubic meters per second, which is considerably more than the figure we need of 50.35 cubic meters per second. But that's okay. It simply means that the smoke layer will not descend as far as our design height. If we were confident that no fan would be lost to fire, then we would be satisfied with 5 fans, which would have a total capacity of 55 cubic meters per second, and again this is slightly more than is required. That's step 7 covered, so now we can move on to step 8, the stagnation check.